Around 4.5 billion years ago, the young Earth witnessed a violent impact. It collided with an ancient Mars-sized protoplanet called Theia. The impact was so powerful that it created an enormous debris field out of which the Moon formed. This is known as the Giant Impact Hypothesis, or the Big Splash. Calculations suggest that Theia might have hit the Earth at a velocity of 9.8 kilometers a second at an angle of 45 degrees. The collision would have sent a shockwave around the Earth over the next few hours and created a debris field out of which the Moon eventually formed over the next millions of years. While there's a lot of evidence to support this hypothesis, scientists have found another fascinating thing about it. The Moon might have formed within hours from the debris field instead of millions of years. If it turns out to be accurate, it would be a groundbreaking discovery regarding our natural satellite. But how did astronomers arrive at this conclusion? How could such a catastrophic collision form the Moon in mere hours? Finally, and most importantly, what happens moments after the collision that instantly created something as big as the Moon? The first ever clues about the Moon's formation came from the Apollo 11 mission. When the first astronauts visited the Moon, they brought around 1.6 kilograms of lunar rock and dust home. When these samples were analyzed, scientists found that they date back around 4.5 billion years. This was the first evidence that the Moon formed roughly 150 million years after the solar system. Now this period is considered one of the most turbulent windows in the history of our solar system. Astronomers believe that around this time, the inner solar system had 20 small planets, and it was through collisions with these smaller planets that we ended with our 4 terrestrial planets. The last of these significant collisions with the Earth may have created the Moon. The 24-hour rotation period of the Earth, the size of the Moon, and its current distance suggest that the celestial object that smashed into our planet may have been the size of Mars. Astronomers call it Theia. The conventional hypothesis proposes that as Theia crashed into Earth, it was shattered into millions of pieces. First, the remains merged with vaporized rocks and gas from the young Earth's mantle. Then, over the next millions of years, these pieces slowly mingled into a disk, and a molten sphere of the Moon cooled and coalesced around it. Astronomers have been betting on this theory since the mid-1970s. But recent research introduces a plot twist. The Moon might not have formed slowly and gradually. Instead, it might have been created within just a few hours. So what led astronomers to arrive at this conclusion? If the prevailing theory is correct, then the Moon is made chiefly out of Theia. However, the composition of many lunar rocks analyzed so far resembles the rocks found on Earth. In addition, the lunar rock samples show similar isotopic signatures to terrestrial rocks, unlike those found on Mars or elsewhere in the solar system. This makes it very likely that much of the material that makes up the Moon came originally from Earth instead of Theia. Furthermore, even the Earth's spin and the Moon's orbit have similar orientations, which is quite striking. So to investigate other possible scenarios for Moon formation after the collision, in addition to the existing ones, researchers used a computer program called SWIFT. This program simulates complex gravitational and hydrodynamic forces that come into play during and after a collision. The team ran the program on a supercomputer nicknamed COSMA. It must be noted that simulating such violent collisions is quite complex. One has to keep on testing until increased resolution stops changing the results. So considering these intricacies, the team simulated hundreds of Earth-Theia collisions, assuming different angles, spins, and speeds. Also, they modeled up to 100 million particles. These configurations allowed them to simulate the impact at higher resolutions than before. And eventually, the results caught everyone's attention. They found that only in a few hours, the Moon formed from the ejected chunks of Earth and the shattered pieces of Theia, which means it didn't take millions of years to form as believed. In addition, the models show that more material from the Earth got used to create the Moon's outer layers. Earlier, astronomers thought that a rapidly forming body close to Earth would be subjected to tidal forces. These forces would rip it apart, thereby favoring a slow creation process. But if we consider the recent high-resolution simulations, such a body could survive tidal forces and be pushed to a higher orbit. It suggests that the impact rapidly placed the Moon into orbit rather than creating a disk from which the Moon gradually formed over the years. If you look at these snapshots from the simulations, you can see an early separation between the proto-Earth, shown in an orange hue, and the outer remnant of the impactor, represented by yellow and brown. Then the inner remnant transfers angular momentum to the satellite of ejected proto-Earth, and Theia material and slingshots it into orbit. Here, the particles forming the satellite and the inner remnants are highlighted in purple and green, while the black lines show the estimated orbit. The newly established theory can describe some of the Moon's unexplained properties, like its wide tilted orbit, thin crust, and partially molten interior. This makes it one of the most interesting explanations for the Moon's origins yet. However, we need more evidence to confirm it, so data on the lunar mantle will be required. And to do so, rock and dust samples excavated from deep beneath the Moon's surface need to be examined. This sounds complicated, but it is one of the prime objectives of NASA's future Artemis mission. As scientists gain access to samples from other parts of the Moon and deeper beneath the Moon's surface, it will enable them to check the accuracy of these simulations and to indicate in a better way how the Moon has evolved over billions of years. The histories of our planet and our natural satellite are intertwined, and the more we learn about how the Moon came to be, the more we'll discover about the evolution of Earth.